you go through here, you click the experimenter just to show you how you can quickly optimize that procedure to search for the best parameter for you. You click experimenter here. So when you click the experimenter, this is open for you. I'm maximizing it. So you can see everything is gray here. You have to click setup first. Setup. Run is not possible. You cannot run it now because you need to set it up. The next, you have to click new. I want to do a new setup. Everything becomes available. So you need to select the file. CSV file is going to be used. See? So you browse. We are going to select our. Now this time around, you need to get it right. You need to create a file. This is result destination. Can you see? Because you are trying to run multiple experiments at a go. And all the results will be sent to Excel for you. This is a simple optimization procedure in WEKA that you can run multiple experiments and all the results, you can get it later. So you have to select, I want CSV, and then you can browse to where you want the results to go. As usual, I usually put my result here. The document, I call something they call WEKA experiment. So WEKA summer school. So I want my result to be here. I just give it a name, result file, result 1. So create a file. So, and then the file is stored. Now, the next thing is you need to data set. You need to add your data set. And the good news is you can add as many data sets as possible. If you want to run different experiments, just put all your data set and click go, and you can go to sleep. And you meet your result next day. But for now, we are using only one data. So you go in here. So select your data, the same location. My doc, then this is WEKA, and this is WEKA summer. You need to check here that I'm looking for CSV, otherwise you will not see the file, it's empty. So it's CSV file, you can see it will bring it out, open, your data is loaded now. The next thing is now I need to add the algorithm. Now I want to run KNN as usual. So I want to run KNN. You can see the first KNN using K is equal to 1, and Euclidean distance, I'm creating it. 1 is there. I want to add another one. KNN using 3. K is equal to 3 is there. Another one, KNN using 5 is there. Keep doing that until you add as many as possible you want. The next thing I want to add KNN using 5 and add a K. You can add KNN, add a new one, yes, with KNN is equal to 1. And you can also change the Euclidean distance. All the 3 were using Euclidean distance. Now I want to use another kind of distance measure. This time around, let me use Manhattan distance. Okay, I save it. You can see here, I add another one. Instead of 1, use 1, of course, use 1. Manhattan distance is working out. I use 3 for Manhattan. I save it again. I add another one, 5. I'm using Manhattan, as you remember. So keep creating different combination until you are okay. In that case now, let's say I'm done. The next for me to do is to run my experiment. So everything is done. So I can now go to run. See, and I click start. You see, depending on how many you set up, it could take you 1 hour, 3 hours. It is done because I just few algorithm I set up. And you can set up multiple algorithms. It doesn't have to be KNN only. You can put ANN there, several ones there. So the moment you have run, it has finished, started, finished, there was 0 error. That's good. Success. So I can now go to my file and you see your result there in the Excel file. By the way, open the file again. It's going to be WEKA. Yeah, WEKA summer school. The result, you can see my result. This is the result. You can see this is the result of the experiment. You can see here, It's telling you the file I'm running. So if you actually load multiple data files, it's possible. It will finish working with that basis, it will pick the other data and keep doing that. See? So now it's telling me for this experiment one, I use this data set. So number one, yeah, there's something there, keyfold. I left it at 10. I'll show you now. It's running every experiment 10 times. There's no need for that. We could set it to 1. You see, just go here and set your experiment to 1 under the setup. Under the setup, okay, because it has closed. If you set up, because we already run that one and we close it, so we have a new one. Let's say I'm setting up a new one. This is why you're having the 10 result. Here you have to put 1 here. Remember to put 1. Number of repetition, 1. You see, number of repetition, 1. This is very important. So just use 1. And how do I want my data to be run? You can see here I say I'm doing classification, cross-validation. No, I don't want to use cross-validation. I want to use train test percentage, 70, 30. It will ask me to put the percentage. I put 70. You see? So I put 70 and I say, okay, number of repetition, repeat it only 1. I don't want repetition. And I start adding my data as the case may be. My algorithm, as we have done, add the k-nearest neighbor for 1, and you do it for all of them, and then you run the experiment. You click here, and then you can start, and it will run your work. However, let me clarify the file. You can see that here in this file, the result is here. You can see all the results. The percentage is what we want. Percentage correct. You can see this is percentage correct. So you can just go to Excel and take your result, and you can see the one that is better for you. You know, say, okay, which one is better? 98, 98. So you select the one that is better and see what is the value of K that makes it to be better. This is what you have to do. You see, you'll be able to detect, to trace out the number of K that is better for you, that got the best result. This is the essence of this kind of automated hyperparameter optimization. So once you have run several results and they are put in Excel for you, you just check, see which one gave you the maximum result here. You can see, okay, what is the value for that maximum result? What is the value of K? What is the value of distance measure, Manhattan, shape, or Euclidean? You still have other results here. There are several others. Some of them you don't need it, like false positive. You just take what you need and you throw away other things, depending on the problem you are solving. You can see the weighted average, the options you have used in the computation. So this is, in short, how we use WEKA to do optimization of parameter, of the systematic parameter search. Like I told you, parameter optimization is a very big area. You have GA, genetic algorithm, PSO, particle swarm optimization, and so many optimization approaches. However, this is a very simple one that someone doesn't want to write programs for those kind of higher one. You can use it and you can get your results, actually. I still use WEKA even for my work. Some of our work are done in Python, some are done in WEKA. So depending on the availability of time we want to spend and the data set we are using. So this is the simple way you can do your simple, what I call systematic optimization in WEKA. Set up, create a new system, and then you can add it. You can add the number of, you have added one, add more, add as many as you want until you are okay. And then you can click, go to run, and you click your start, and then your result will be started, and then it will tell you when it ended. So this is how we use WEKA for automated parameter search, or for running multiple experiments. Let me call it this way, for running multiple experiments at the same time. So you can actually use this kind of option, and you can set up different data sets at a time or different algorithm at a time.